Good evening, everybody. Wherever you're joining us from today, we're dialing in from San Francisco here. We have a live chat here, so you can let us know where you're dialing in from. We have quite a few folks already on. We're excited today for our webinar. We'll be talking about how you can train smaller, faster LLMs for your use case that can outperform GPT-4 at a fraction of the cost using data directly from your data cloud. So we have a great sort of better together story with Predibase and Snowflake, and we're excited to talk about that and then show you in a live demo what that can look like for you. So let's get started here. Next slide. A few things. So one, I'm going to push out some polling questions real quick. So as we wait for folks to join, we always think it's fun to have some polling questions. Let's folks kind of share amongst each other where they are in sort of their LLM journey, that kind of tools and techniques they're using, so you can participate in those. They'll be in the sidebar there. We also have a handout that I'll push out now, which is the webinar slides. So people love to download the slides. Obviously, we'll be covering today, but if you want to download them for yourself, you can go ahead and do that. So you'll see that in the sidebar right where the chat is. There's a chat, or next to the chat, there's a few tabs you can click through. Few logistics points. One, we are muted today, but we like this session to be interactive. And what I mean by that is we will have a live Q&A at the end with our speakers. So if you have questions throughout the presentation, throughout the demo, please put them in the sidebar. We will definitely get to them at the end. And also we have some of our engineers who join who can answer some more technical questions in chat as well. So we'd like to get the conversation going. So please don't be afraid to put your questions in chat. Session will be recorded. So if you have folks on your team, peers who may not have joined, you'll get a replay of the webinar recording directly after in your inbox that you can watch or share. I mentioned we have some polls as well, and we talked about the chat. And of course, if you're interested in trying Predibase, we always encourage you to. We'll give you $25 in free credits to go ahead and fine tune and insert some open source LLMs. And you can do that by going to that URL or our website, and I'll post that in chat in a minute. And with that, I'll introduce our speakers. So we have two awesome speakers today. We're joined by Rajiv Shah, who's an AI strategist and leader at Snowflake. Rajiv has been with many of the big names in AI. So if you want to learn about what's going on in the AI landscape, I can't think of somebody better. Raj has been at places like Hugging Face and Snorkel, some really leaders in ML research. And he's joined today by our Predibase founder and CEO, Dev. Obviously, we work very closely with hundreds of organizations who are interested in taking best of breed open source models and train them for their use case and serve them. And so he'll be sharing a lot of insights that we've learned working with those organizations and how to be successful with LLMs on your own. So with that, I'll pass over to Dev to kick us off with the content today.
Thank you very much, Michael. So I'm really excited to be able to do this webinar with Raj. Raj and I have known each other for a number of months, and really started to speak a bit about what do we see in the market when people are starting to use Gen AI. And I actually think that both of us share kind of a similar view as we think about like the enterprise AI market. And I think this is informed by one of our favorite customer quotes. So one of my favorite customer quotes is, "Generalized intelligence is great, but I don't need my point of sale system to recite French poetry." This is a perception that I think we've seen at an increasing rate come up in the market, which is this idea that while really large models are, an effective starting point, there's some amount of the capacity that's really overkill or wasted when you want to solve a very narrow business task. And instead, organizations, I think, are really focused on that last mile problem that AI often has. As a result, we've seen a trend where OpenAI has become one of the best starting points for organizations that are looking to be able to experiment or prototype with generative AI. Most teams that we work with start with larger commercial LLMs like GPT-4, which gives them great performance out of the box and a really easy to use API interface. But as we start to think about organizations moving into higher volume settings, going into production or running more batch workloads, we see that while some of these larger APIs are great for rapid experimentation, our customers tell us that they really have a few key issues. The first is the largest variants of the models might be expensive at scale. They may be a little bit too slow for the individual tasks that a user is trying to do, which is not surprising given just how many parameters exist in some of these models. And fundamentally, organizations tell us that they have some concern about the lack of ownership or control over that model. So while we think OpenAI is a fantastic place for every organization to be able to just get started in understanding what generative AI can do for them, the future that we see is that, and the destination that we see off that starting point is a series of smaller task-specific models that are really fine-tuned towards individual tasks. And the main benefits, I think, of being able to take that approach is you own your models. You can get smaller, cheaper, faster models, which is really going to be an orientation that we have today as we talk about a collaboration with Snowflake and the Data Cloud. And you have full control over both your access towards your data as well as like the underlying models that really are supported there. And so the future, I think, that we envision and a lot of organizations, are bought into is this idea of small, task-specific, open-source models really dominating the type of enterprise workflows that organizations will want to be able to use to deploy Gen AI into production and go past just that prototyping phase. But if you ask me, like, what the number one concern I hear from organizations that are considering open source models, it really is quality. Are the open source models good enough? One customer I talked to said, Dev, I want to believe that open source models are the future, but GPT-4 is just so good, I don't know if I can get that same level of quality from these open source models. To be able to tackle this head on, we just did some investigation earlier this year, where we fine-tuned a smaller model, in this case, Mistral 7B, across a set of different tasks, everything from code generation and question answering through classification, sentiment detection, toxic comment identification, and more. And our real intent was to understand when we benchmarked a fine-tuned version of, for example, Mistral 7B versus GPT-4 with a little bit of prompt engineering, how did these two models compare? And what we found was actually in the vast majority of settings, in about 25 of the 27 cases that we benchmarked on, fine-tuned Mistral 7B not only matched, but actually started to outperform GPT-4 when compared kind of on that in-domain task. And so this was a really interesting moment for us. And we wanted to share the results with the world. And so we put out a launch that we called LoRaland. It's essentially 25 fine-tuned LLMs that really rival GPT-4. We put together an interactive web application where you could start to play around with these LLMs and just start to get a sense of how did a certain model work when you compared its fine-tuned version versus its base version and others. And this launch went, we like to say, semi-viral. It was trending on Reddit and Hacker News and others. And I think really because it started to give people the evidence that smaller task-specific models could actually outperform larger commercial ones. Our motivation here was really to be able to do a few things. The first was to be able to demonstrate that with fine-tuning, you actually can get better than GPT-4 quality once you're able to apply it towards your data set. We wanted to show that you have the breadth and flexibility, that you can solve many different types of tasks with parameter-efficient fine-tuning, which is what we really call, which is why we decided to name the website LoRaland. That we can build a real application, in this case, a website that anyone could go ahead and be able to access that allows them to play around with and test out these models to be able to see what it actually looks like when end users face this traffic, and that you can have very cost-effective serving. The entire application that served 25 different fine-tuned models was really just using a single GPU, using a serving framework that supports multi-LoRa inference called LoRax. I'll touch a little bit more about what exactly LoRax does in the future. But I think the main thing that I wanted to be able to call out was we were, I think, both very happy and a little bit surprised at how much the community had uptake around this LoRaland launch when we announced these 25 fine-tuned LLMs that rival GPT-4. And so we decided to take it one step further. One of the most common questions people asked after we put out LoRaland was, great, you've shown this for Mistral 7B, but which model should I really use for my specific task? You know, I've heard about things like Zephyr or Gemma from Google came out literally 2 days after we put out the LoRaland launch, and Llama 3 came out a few months later. And so what we did is we actually upscaled from just 25 different fine-tuned models to over 700. And the way that we got there was we fine-tuned 12 of the most popular open source LLMs on over 30 tasks and ran multiple runs across instruction-tuned and non-instruction-tuned versions. And what we found was that the real difference, what we found was a few different things, actually. Number one was a definitive leaderboard of kind of which models did the best on the 30 different tasks that we call our fine-tuning index. You can look at this research directly at predibase.com/fine-tuning index, and it'll give you a sense of how many data points did we benchmark on, which model variants were the best for an individual task, and which ones were the best in aggregate. The second thing that it allowed us to be able to do was really make, I think, the data-driven argument that fine-tuning and fine-tuned models is really the difference maker. So what we saw was, predictably, when you compare just base model performance, the people that have concerns about open source models are correct. GPT-4 and even GPT-3.5 Turbo really, I think, strongly outperform any of the smaller model variants that we had experimented with. But when you add in the fine-tuning bars against the prompt engineered GPT-4 models, we actually see significant lift. And you start to see many different model variants, Llama 3.8b, even 5.3, Mistral, and others, really start to become much more competitive with the larger commercial models. And so for us, I think that this is kind of a real kind of indicator of why we believe the future for these models is fine-tuned. But we understand that there are some challenges with actually getting this to work inside of an organization. And I'd say after people buy into this idea that for cost, speed, and quality reasons, fine-tuning is something they're interested in, what we really run into is that fine-tuning feels like inside of a lot of organizations, it's going to be a heavy investment, or that there's going to be a long time to value due to the complex architectures. And there's a few different challenges that I think really exist here. The first challenge is that data lives in siloed systems. Fine-tuning is only as effective as the data that you actually use to be able to create and train those models. And that means that you need to make sure that if you have data in a table somewhere, unstructured data, oftentimes organizations need to be able to rationalize where all of this lives and exists and be able to pull that in to one source that they can actually start to use for fine-tuning. Once you've solved that data problem, you then have your next problem, which is there's so much cutting edge research that is coming out. It feels like every week in terms of how to best fine tune your models, and a zoo of different open source frameworks that people use to stitch together and glue different code snippets to understand what actually could work well for them in production. And then finally, you have to think about not just fine tuning the model, but how you actually want to manage your own infrastructure for being able to go ahead and deploy these models, especially if you're self-hosting. All of these things bring you benefits. Self-hosting gives you control, more flexibility around cost. But I understand that all of these also introduce a lot of challenges for organizations that are thinking about moving to a future that is more open source. And that's where Predibase and Snowflake's partnership is really coming in. We want to accelerate the development of open source LLMs by making it much easier for organizations to solve these three key challenges by using our joint integration. And in particular, I think Snowflake is one of the best places for having all of your data in one place that can be connected using the data cloud to the models that you actually want to be able to train and fine tune. And then Predibase looks to solve the challenge of making it very easy and efficient to fine tune models. We've made a number of different optimizations over kind of what you would get base and out of the box fine tuning libraries, and built a very easy to use no code and low code SDK to be able to go ahead and start to actually use these models in practice. And then finally, we've built a really compelling serving infrastructure for being able to make sure that you don't have to manage many GPUs when you're actually deploying these models directly themselves. And this is kind of what we wanted to talk through in our conversation today. I think we believe that the future is these fine-tuned and open source models. And the real challenge that we all have is how do we make that future a lot easier for organizations to realize? So that's what we're excited to be working on directly with Snowflake. And I'm going to hand it over to Raj to talk a little bit about the first element of this, which is what Snowflake is and how the data cloud really solves some of the key data gravity challenges that exist when using generative AI applications. So Raj, I'll hand it over to you and then come back to talk a little bit about how Predibase then fills in the gaps for the fine-tuning and serving pieces.
Excellent. I'm looking forward to this. Let me get my screen shared here. Now, I want to start by just talking a little bit about kind of fine-tuning in Predibase. So before I joined Snowflake, I was at Hugging Face. And one of the things that we ran into is lots of folks were using these large language models, but they were paying outrageous bills for folks like OpenAI. And we introduced some of our customers there to the idea for some specific tasks, you could fine tune a much smaller model, have it under your control, able to reduce costs quite a bit. And so that's where my own experience taught me the value of fine tuning these models. And this is where I've blogged about it. I've seen Predibase has been a leader in this area, which is why I'm here and why I'm excited to talk about it, because I think it's a great solution for a lot of tasks that we're working on around that. Now, I left Hugging Face. I joined Snowflake. I'm very excited at kind of Snowflake because Snowflake is, as Endeavor was mentioning, the place where lots of organizations have all of their data, giving people this unified strategy around data and AI that supports a variety of personas, from SQL analysts to data engineers. And now, one of the things I'm excited about is not only that traditional data warehousing, but also lots of machine learning as well. And so within Snowflake, we can handle lots of different types of data. We've added the ability to have different types of compute. So you can have CPUs, you can have GPUs as well, but then put services around that to make it easy. If you're familiar with the data engineering side, we have tools like time travel, so you can go back if you actually drop a table, replace it. Well, we're looking and seeing what are the same issues that folks in AI and machine learning have. Can we build certain services around that? So what we've done over the last year is really build a comprehensive machine learning platform for if I'm a traditional data scientist, I have an XGBoost, I need to get that out with modeling and with feature stores and model registries and all of that. But really what I'm also excited about is everything we're doing on the generative side as well, where we've put together model gardens for folks to be able to work with lots of leading models, our own proprietary models, our open source models as well as adding some nice services on top of these. So if you want to do a RAG application, you want to talk to your data, we're building some of those solutions for folks at the end of the day. So here's a simple, quick example of this. So I'm using Streamlit, which Snowflake acquired, kind of has that open source right inside there. Very common kind of application where I want to be able to ask questions to my data. And so I live in Central Illinois, so I ask kind of Rivian questions. I can ask how many vehicles you manufacture. This one is a RAG use case that goes back to kind of 10Ks. I can see the original parts of the document as well. And the great thing is, all of this is running inside of Snowflake. So I have embedding models that are serverless inside Snowflake. We have cosine similarity, large language models as well. So this entire stack that you need for generative AI, even including some fine tuning, is all available inside of Snowflake, which is why I believe it's just a great platform for doing not only your traditional data engineering, but also now as we move into kind of AI and generative AI, all of those applications. But the great part is we have great partnerships with other folks as well to extend those ML capabilities, because our fine tuning isn't going to cover every scenario as well. So I'm going to hand it back here to kind of let you talk about some of that.
Thank you very much, Raj.
Yeah.
And so to take over, I think from Raj, where Raj was kind of giving us the context, Snowflake has built kind of a data cloud that allows organizations to be able to work with their data warehousing system and build the next generation of machine learning workloads on top. And one of those next generation workloads, I believe, is fine-tuning models more effectively. The key, I think, that we think about at Predibase is how do we make it easy and efficient to be able to fine-tune lots of different models that you might want to be able to run your experiments on, and then be able to serve a lot of those models directly in a more kind of transparent way. And so where we think about solving this initially has actually been in the open source. So at Predibase, we're the authors and creators of two underlying open source technologies, Ludwig and Lorax. Ludwig is our training framework that allows any organization to be able to fine-tune a deep learning model or an LLM declaratively. And Lorax is our serving and inference framework. So you can think about Ludwig on the left as how we train and fine-tune models, and Lorax on the right is how we think about serving an inference for those fine-tuned LoRa models. The key intuition behind Ludwig is that you can build a fine-tuning pipeline declaratively. Simply in a configuration-driven way, you can suggest what is the fine-tuning job that you want to be able to set up. But because it's configurable, you can actually go ahead and customize that fine-tuning job down to the level that you might need. For example, if you wanted to change the rank of your LoRa matrix or add in dropout, you could just do so easily and declaratively. The second open source framework that we have is around inference that we call Lorax. Lorax is a very unique way to think about how to serve fine-tuned models. And it takes advantage of the fact that in most instances, when you fine-tune inside of Predibase, you do a parameter-efficient fine-tuning called LoRa. And with LoRa, you only customize a small subset of the overall weights of the model, usually much less than 1%. Traditionally, when organizations were deploying fine-tuned models, they were spinning up every fine-tuned model on its own individual GPU. And that meant if you had 5 different fine-tuned models, you might have 5 different GPUs that a user might be actually running that compute directly on, which could get quite expensive at scale. Instead, the way that Predibase thinks about deploying fine-tuned models is to multiplex a single deployment to be able to support many different LoRa adapters and many different fine-tuned LLMs directly. So you can host one base model deployment, for example, Llama 3 8 billion or Mistral 7 billion, and bring many users fine-tuned LoRa adapters directly towards that base model and be able to run inference and serving against that directly at scale. So Lorax is a framework optimized for multi-LoRa inference, and in particular, how we think about users inside of Predibase being able to deploy many fine-tuned models, all for the cost of one. Predibase then is an end-to-end platform that allows a user to go from prompting to fine-tuning and then deployment. We allow an organization to choose any open source model or data source and proprietary data source, with one of our preferred connectors being to Snowflake, where you can connect directly from any of the data warehouses and tables to underlie that system there. From there, you can efficiently fine-tune LLMs using underlying Ludwig open source framework and a proprietary version we have of that. You can then track, iterate, and compare different versions of these fine-tuned models. And inside the platform, we call these fine-tuned models adapters. And then finally, once you're ready to deploy an adapter, you can actually use a serving framework, Lorax, to be able to deploy those cost effectively at scale. And all of this is built on top of fully managed and like serverless machine learning infrastructure that can be deployed inside of our SaaS environment or deployed into a customer's account in their VPC, whether that's AWS, Azure, or coming soon directly into the Snowflake Data Cloud itself. So with that, I want to just indicate, this is what the Predibase platform really provides out of the box. And I think a couple of key things that I wanted to mention is what makes fine-tuning in Predibase special beyond just the fact that I think it's easy to use in an integrated end-to-end solution. And the two things that I think people really care about when it comes towards fine-tuning is quality and speed. And so on quality, we find that on average, organizations get better quality for their LoRa adapters when fine-tuning with Predibase rather than using, for example, an out-of-the-box open source fine-tuning framework. One of the main reasons for that is we've done extensive benchmarking, trained several hundred models across many different data sets, and found what we thought, and customized kind of our recommended settings for any fine-tuning job to the model and data set that a user decides to connect into our platform. So we've run through a number of different optimizations, like making sure we do the right thing with input loss masking, automatic batch size tuning, smartly tune the learning rate. And what that really results in is all you need to do is be able to kick off your fine-tuning job, and rest assured, Predibase is going to find some of the best recommended settings for you to be able to get started. So the first thing I think people really think about is quality. And then the second thing I think that is important is speed, or in LLM parlance, oftentimes referred to as throughput, which is the number of tokens per second an individual model can actually generate for you. And what we see is that, especially with LoRa fine-tuning, we see that we have a very unique feature in the platform that we're going to GA in the next 2 weeks called Turbo LoRa. And what TurboLore does is something that I haven't seen in any other platform before, but allows you to be able to jointly fine-tune for both quality and speed. So with TurboLore, we actually see speedups of anywhere from 50% to 3x faster LLM serving deployments for fine-tuned LLM models over more traditional open source LLM frameworks like VLM. I think this higher throughput really ends up mattering for our customers, because better throughput not only means better latency in kind of like the response time that a model might take to be able to get back to you with an answer, but it also means you can get more out of your own GPU, so that you can actually, so that you don't have to spend as many GPUs or spin up as many replicas when you get higher load. So with TurboLore, customers get a better bang for their buck when they think about actually using each of their LLM fine-tuned deployments. And finally, all of this is kind of natively integrated with Lorax, which provides significant cost savings when you're deploying more and more tasks and more adapters versus needing to be able to spin each of those up, as different OpenAI endpoints directly. So that's a little bit about what Predibase and Snowflake are sort of doing in a high-level overview, and kind of as we think about slides. And from here, I wanted to just be able to jump into a little bit of a demo for where we can show you how to be able to do this yourself. And we've actually tried to make it as self-serve as possible. So if anyone wants to follow along and create their Predibase and Snowflake accounts to get started, I think this can be an easy way to be able to attack that. So in this particular demo, we're going to be doing something around automated contract review. And so there's a data set that we have found available on the Snowflake marketplace that allows us to test out automated contract targeting, or automatic contract tagging that the US government often needs to do. So what we've seen is that this data set consists of many contracts that the US government has essentially put out. And typically this requires thousands of full-time employee hours in order to be able to manually tag and append missing metadata. For example, determine which government agency a given contract should go to, what's the vendor name, fiscal year, a number of these types of boring tasks that I think are really actually optimal to be able to get solved with AI. And so what we're going to show is just a very simple example today, which is how we can ingest contracts that might exist somewhere in Snowflake and be able to do tagging in a more automatic fashion using a fine-tuned model inside of Predibase, and how to be able to use the combination of Snowflake and Predibase to be able to go ahead and attack those. So in order to be able to actually demonstrate this, I'm going to go ahead and first show you a little bit about where this actual data sets came from. So here I'm actually logged into the Snowflake platform, and I'm going to show you the Snowflake Marketplace. The Snowflake Marketplace is a great platform for being able to get started with different data sets that are actually available for you to be able to query immediately, hosted from different organizations as well. Our first data set is coming from Cybersyn. And so this is a data as a service company that's actually put out a number of different free data sets that you can start to play around with directly inside of the Snowflake Data Marketplace. And you can see that there's data comprising everything from SEC filings to US points of interest and more. But what's really interesting is they actually have a data set and pack right around LLM training essentials, which is where I'm pulling this initial data set from. And they have a few different ones here. They have SEC filings, US patent grants, and the one that we're going to be looking at is US federal government contract opportunities and awards. And so here we can see that there's a number of different fields that exist. But really what we want to be able to understand is how to go from the contract description to, in this case, what we're going to look to be able to tag is something quite simple, like what is the department, what is the name of the agency that this contract is supposed to go to? Department of the Air Force, Homeland Security, Transportation, and others. So this is the data set inside of Snowflake. I can go ahead and open it and create my own tables, start to run my own SQL queries directly over it. But what I'm going to show is how you can actually connect this data set into, from Snowflake into Predibase today, and then get started fine-tuning your own models directly on top of that. So with that, I'm going to go from Snowflake now to Predibase. Once you create a Predibase account, you'll be dropped into this homepage experience. And inside this homepage experience, you can see how to get started with the platform. Now, there's two ways to be able to use Predibase. You can set up the Python SDK and use this fully programmatically. So if you want to use this in a notebook environment or start to query us via REST, you can do so. And we have a very easy to use low-code SDK that will allow you to be able to kick off fine-tuning jobs and deploy your own LLMs. But we also have a no-code UI that allows you to do all of the model building and even the deployment directly through this platform. And that's what I'm going to show you in terms of creating our models really here today. Now, inside of Predibase, things typically start with the data. And so the way that users get started is they connect their fine-tuning data sets from any number of different data sources that we might have. We have some documentation about what your data could look like, but in general, Predibase supports two different fine-tuning techniques. Instruction fine-tuning, where you have two columns, prompts and responses, and you want to teach the model by example about what a given task should look like. Or completions fine-tuning, where you can just point it towards a text data set and essentially allow it to be able to learn how to complete the other types of verbiage that should be in that text. In this case, I'm going to show an example using instruction fine-tuning. There's really two steps towards, I think, creating a data set inside of Predibase. The first is you enter your credentials to create your Snowflake data connection. So you can give us the username that you want to be able to authenticate into, the account identifier, database name, schema, and the warehouse that you want to be able to use to run that underlying compute. And once you configure this, you'll be able to create your connection towards Snowflake. And from there, for example, I have my connection that's called US government contracts. I can go into that connection and actually import in any of the data sets and tables that exist as part of this. You'll see that we spend just a couple of seconds noting which tables are actually available from this connection. So which ones you have access to as part of the credentials that you really put in here. And I can start to load in any of the different data sets that I might have directly. So in this case, I've already loaded in the data set. So I'll show you a little bit of what that actually looks like right now. This data set is the US government contracts data set. And you can see that we have a few key columns here. We have the contract description, a prompt that we've essentially used to be able to prompt engineer to understand how to increase the model performance out of the box. We included this prompt column in particular to be able to include a lot more context that would make it easier for GPT-4 when we benchmark against GPT-4 to note how to classify the model. And then finally, the completion. So this is the actual classification of which agency that we believe that this contract should go to. So you can see some basic metrics like how long each of the contracts are. So in this case, it looks like the average contract description is about 550 tokens. And you can see things like what are the types of classes that we actually look at classifying these contracts into. Department of Defense, Homeland Security, Department of Commerce, and so forth. A given contract can be quite messy, essentially, to look at. So you can imagine it would take somebody a fair amount of time to actually go through this and manually tag it with what's the department that I actually want to be able to route it to. I want to show you a little bit of what the prompt is that we actually also put into this column that essentially asks the model to say, you're an expert in the US government contracts. Here are all of the different agencies that a contract could actually go to. Please return only the exact name of the department without any explanations, and then gives the description or the contract description from this former column. The reason we made that prompt so long was we wanted to make sure we did some prompt engineering that would help us understand what does good GPT-4 performance look like out of the box. So when we compare it to a Predibase fine-tuned model, we have a really fair apples to apples comparison overall. So this is a little bit of the data set that gets created. It's about 5,000 rows coming from Snowflake. And we're going to try and see how we can actually train a fine-tuned model to go from this contract description towards the classification overall. Once I've connected and created my data set, I can go over to my adapters page to be able to actually train and fine-tune any of these models. And in particular, I'll go to my US government contracts repository. And a model repository inside of Predibase is essentially a collection of different fine-tuned models I've used to be able to attack a single task. Building a new adapter or fine-tuned model is really easy. All I say is I want to create a new model version, and then I point it towards the data set that I want to be able to train on. So in this case, I want to train on the US government contracts data set I just showed you. And from there, I only have to choose one thing, which is what is the model that I want to be able to go ahead and train. There are a number of different popular open source LLMs that are supported first class out of the box inside of Predibase. Everything from Llama 3.8 to Code Llama, Gemma, Mistral, Zephyr, Phi, Quen, the new Quen models. All of these are just supported out of the box directly through our drop-down menu. And you can actually go ahead and select one and then click train immediately. If you want to adjust any of the additional hyperparameters, like the adapter rank, which target modules you use, how many epochs you want to train for, or others, you can do so. But in most cases, users get started using just kind of our recommended and out-of-the-box settings. So once I go ahead and click train, we'll go ahead and handle spinning up the GPU resources in order to be able to start training this model. And you'll be able to monitor that training job directly. You can click into any given model and provide a test and evaluation split, so you can track different metrics over time, like how the validation versus training loss are going, as well as how long this model actually took to train. In this case, for Llama 3.8 billion over those 5,000 rows, it took about 2 hours, 2.5 hours to be able to train that model. Once I've trained that model, the really cool thing about Predibase is it's automatically available for querying and deployment. And I'll just show you a little bit of how that works immediately. So the first thing we can do in Predibase is go into our prompt playground. And this is a way to be able to start to experiment with any of the different models that a user might have overall. We automatically host a number of different base models, things like Llama 3.8 billion Instruct, Solar, Code Llama, Gemma, Mistral. Any of these models are really supported out of the box, and you can start to query them today. So I can ask Llama 3.8 billion to say hello to our webinar audience, and you'll see that this base model really does actually respond directly and reasonably quickly to our kind of results. But where I think things get interesting is when we actually want to use any of these models and LLMs to be able to classify any of the contracts that we had earlier. So what I'm going to do is I'm going to copy and paste a contract that I actually pulled in from my Snowflake dataset just into this prompt window and ask Llama 3.8 billion Instruct to be able to classify it. Now, this contract is about the FAA's requirement to upgrade the fire and life safety features on one of their particular buildings. This contract, I happen to know, should be sent over to the Department of Transportation. And so what I'm going to do is I'm just going to query my Llama 3.8 billion base model to understand what type of department is it going to classify it as. And I can go ahead and click run to use that classification. And we can see that Llama 3.8 billion, given all the prompting that we've done, does give a department back, but it's the wrong department. It's the Department of Defense. And that's not that surprising because this model, while it's smart, has not really been fine-tuned towards the specific data set that we actually had trained it on. And so what I'm going to do is for my next query, I'm going to go beyond just using the base model. And I'm actually going to pull in the fine-tuned adapter that I just kicked off, which was my US government contracts adapter. And now, immediately, essentially, I can use my fine-tuned adapter on top of Llama 3.8 billion Instruct without having to redeploy any new infrastructure. And I'm going to run this query. And you'll see that it correctly identified that this contract actually was about the Department of Transportation. So this is a really simple example of how fine-tuning can actually improve model performance and how you can start to use many different versions of fine-tuned adapters and models directly on top of any base model. If I had a different fine-tuned adapter, not only for the agency, but for the date that something was filed in or the vendor name for who had actually made that contract, I could actually very easily just run all of those queries on top of a single base model Llama 3.8 billion using different adapter versions. And it would be a simple way for organizations to get a lot of meaningful lift directly across any of these different tasks that we have. Now, one of the things that we had mentioned right out of the box is that you can use Predibase programmatically. And so if you wanted to be able to not only kind of query this in the prompt playground, but be able to use our REST APIs, you can check out the documentation that we have to be able to see how you can actually start to use this in production. So if I want to start to classify my contracts at a high scale, I don't have to copy and paste it every time, but I actually can use this directly via REST. One of the things that we had kind of mentioned at the top was how smaller task-specific fine-tuned models can actually outperform larger models like GPT-4. And one of the other items that I'd mentioned was we built some kind of prompt engineering to make sure that it was a good comparison between the small fine-tuned model and GPT-4 as well. And so when we benchmarked on this specific task of contract tagging, we found that with the prompt that we had created, which listed all the department agencies, asked to only put out one, GPT-4 did reasonably well out of the box at about 83.4% accuracy. But with the Predibase fine-tuned model, the exact one that I showed you, just using the default and recommended out of this box settings, we got nearly 94% classification accuracy out of the box. And this is pretty consistent with the findings that we've had over and over again, which is that fine-tuning within domain data is going to allow you to have a smaller, faster open source model that really kind of works at a fraction of the cost. And so that's what I wanted to show you in the demo today. And the very last thing I wanted to indicate is kind of that with our Snowflake partnership, we've just achieved kind of our first milestone and have that live to be able to use in the product, which is a high throughput data connection to any of the tables that you have inside of Snowflake and being able to run those inside of your Predibase cloud environment. But one of the things that we're really excited to partner with Raj and the entire team on Snowflake with is our upcoming roadmap to bring Predibase actually as a native application that can be deployed directly on top of Snowpark container services. What that would allow us to do is be able to run the entire Predibase platform inside of an end customer's Snowflake account. And the real implication of that is that your data and compute, in this case, don't need to be connected to Predibase, but actually you can use the GPUs that exist as part of the Snowflake Data Cloud and be able to start to fine-tune models directly inside of that kind of secure container environment. This is something that we have just begun work on, and we're actually actively looking for design partners who might want to work with us on kind of this initial code development and start to be able to fine-tune any of their models directly inside of their individual Snowflake instance. And so if you have any interest in being kind of one of the early adopters for what a Predibase solution could look like running inside of a fully managed Snowflake environment, please do reach out to us. And we'd love to go ahead and talk to you about what we're working on together hand in hand with Snowflake to actually build out this kind of more robust integration. And with that, I'll say thank you very much for listening towards kind of this presentation so far that allowed you to see how Predibase and Snowflake kind of combine to be able to help you build smaller task-specific models that really are optimized using the Data Cloud. And we'll go ahead and turn it over for some live Q&A.
Awesome. I see a lot of questions in chat. Keep posting them, but I'll just start with maybe some that were from early in the presentation. Somebody asked, probably like this, Deb. I don't think we've actually have this today, but someone had asked, do we have like some sort of portal or benchmarks comparing like pricing of SLIMs versus commercial LLMs, proprietary models for different use cases? I've thought about what's coming, but maybe you want to share your opinion on that.
Yeah, it's a great question. We have a couple of benchmarks that we've put out in the past. So if you go to the fine-tuning index, you'll get a rough sense of like how pricing for some of the small language models works against larger commercial models like GPT-4. But I think as Michael was alluding to, we're actually really looking forward to putting out a more formal calculator that will help organizations understand for a given workload, a number of tokens and a certain model, how that might actually compare against GPT-4. So we don't have that asset out yet, but I think it's going to be out in the next few weeks. And I'm really looking forward to being able to share that with folks directly.
Awesome. Hey, there's some questions about how we think about like pricing. Can you do pay-as-you-go fine-tune, open source models? That was one part of the question. Also like hosting options, in their cloud versus our cloud. Maybe you can talk about that a little bit.
Yeah, definitely. So two different things there. The first is pay-as-you-go pricing, and then the second is where this platform actually deploys to. So with pay-as-you-go pricing, Predibase does actually have a developer tier where you can get access, which I think is like great, especially for experimentation and getting started. And so here you can just add a credit card. We get some credits included kind of as soon as you create the account. But you can add a credit card and you can start to fine tune any of your models directly. And so you can see all of the ones that we support out of the box. And you can even get an estimate of like how much your fine tuning job will cost. From there, you can run inference, up to 1 million tokens a day against our serverless LLM inference endpoints, or spin up your own dedicated deployment, which is going to be the easiest way to be able to actually run a more production ready application. And if you're starting to do anything in production, of course, we'd love to be able to talk to you. So that's, I'd say, the easiest way for anyone to start to use a pay-as-you-go option. In terms of hosting, we do support 2 different ways to be able to use Predibase. You can use it as a fully managed in cloud environment, in which case we manage all of the compute, or we can deploy into a customer's VPC. So we can deploy, for example, into your AWS account or your Azure account. And this is what we're really looking forward to be able to extend with Snowflake too, where this entire platform could run really directly inside of your end customer Snowflake account.
Awesome. And any thoughts on, maybe quick mention like data privacy, security, and some of the recent things we've done there? Like
Yeah,
SOC 2,
definitely.
Yeah.
So we are a SOC 2 compliant platform. So on our SaaS offering, we have some of the best practices in place for data privacy. And but if you want to go beyond that and have something where data never leaves your cloud environment, that's something that we support the VPC deployments for there.
Got it.
Can I ask, like, what are the use cases or tasks that you find work best?
Yeah,
Like,
it's a great question, Raj. And I think that, one of the ways that I'll answer this in 2 parts. The first is we have some data to show, like, where do we actually see different tasks perform well against GPT-4. And so we have a number of different data sets that really represent different types of tasks, from classification to question answering, named entity recognition, and others. And you can actually see, just in a data-driven way, what were the types of tasks that different models actually performed well on. This is like a deep dive that you can get into using the Predibase fine-tuning index. But in terms of my anecdotal and sorry, just to show you the different types of tasks, you can see that we have classic NLP, coding, knowledge, reasoning, math, and others. And you can see for a given thing, like, for example, news topic extraction, which model did the best. But to kind of answer anecdotally, Raj, as I've been talking with different customers, what types of tasks and use cases people have, it really, I think, comes down to 3 types of use cases that are great fits for fine-tuning that we've seen over and over. The number one is actually classification tasks. So like tagging or classification. We work with a customer, for example, that has financial transactions, and they need to be able to classify them into a number of different buckets. Or similar to the one use case that we showed today, contracts, and you need to be able to figure out which department do they go to. The second task that we see oftentimes is summarization. So, for example, you might have call transcripts, and you need to figure out how do you actually want to be able to summarize those. And the third is information extraction. Now, 5 years ago, we called information extraction named entity recognition. And now I think we're calling it, info extraction. But I think that's another great candidate for some of these LLMs. Raj, from your experience at Snowflake, what are some of the tasks that you see people using Gen AI for most frequently? And then also, have you seen kind of, which ones people start to use open source models and smaller ones for?
Yeah, so let me first kind of chime in on the fine tuning, because I have a similar kind of intuitions as well, where I think it works best where the data you're working with is slightly different than generic data, Wikipedia data that GPT-4 might have been trained on. So when you have a slightly different data, and I think it's magnified when you're doing this multi-class classification, where you have your data like you talked, and you have 50 categories, but the categories might make sense to the company, but GPT-4 is a little confused because maybe the company and how they categorize things isn't like how you would do it if you just read Wikipedia. So I think those types of tasks where it's a slightly different shift, I think are really great examples for kind of taking the time to fine tune a model. You're going to get big payoffs for that. In terms of these types of tasks, I see a lot of stuff where people want to do this extraction out of data, where you have lots of unstructured data. You want to pull it into a tabular style so you can do lots of other kinds of analysis. So whether you want to do classification, whether you want to extract certain names, companies, locations, all that stuff out of it, and just have that run in an automated way, a very reliable way. That's a great one for generative AI, where you can get away a little bit from all this issues of hallucinations and unreliability, because these things are much more reliable like that.
I think that's a great point, actually, that I just wanted to also double click on, which is people talk about hallucinations quite frequently. And I think hallucinations are often come because these models can be so open-ended in the types of outputs that they generate. And one of the brilliant things about fine tuning is it really provides more structure and guidance about what do you want the model to really output. And so fine tuning actually is a very effective way to be able to reduce the rate of hallucination or kind of errant responses from an LLM. So yeah, great point, Raj, there.
Sorry, I'm messing with the mute button. That a couple of bolt-on questions to that, because there was some discussion in the Slack around use cases. One, the use case we showed today, maybe just like identifying contracts. Someone says maybe simplistic. Can we do more complex use cases like generating an output as JSON, structured JSON, which is, I think, related to what you were talking just now.
Yeah. And so I totally agree. The use case that I think we wanted to obviously go through a fair amount of content today, but the use case I would say is both simple, boring, and also very common for the one that we showed today. The nice thing is you can go way beyond that inside of Predibase. And so we actually have a blog that shows how to do things like, generating JSON for structure generation using Lorax and a framework that we call Outlines. And where you actually get significantly better model performance using kind of a fine-tuned model that also does kind of constrained decoding to be able to actually have better JSON extraction. And so if you're interested in kind of like checking out this, we're going to put out a little bit more of a deeper kind of introduction towards this actually as an additional blog post in a week or so. But here you can actually see like how you use a model like Mistral 7 billion to do NER again on a particular data set and make sure to adhere to JSON format. So I'll share this directly in the chat. But I imagine, Raj, this sounds very relevant to kind of what you were just saying, which is people have like this unstructured data, they want to extract out structure from it. So do you see a lot of JSON generation and creation as part of like what you see in the Gen AI world?
Absolutely, right? Because once you get that out, you can see sometimes you end up with like spaces or weird commas. So having good structured output at the end is really important. And this is where I think like fine tuning is a great example of where you can kind of concretely kind of make the model kind of act in that particular way and have a better chance of doing that. So absolutely.
So someone had also asked about, just from an industry perspective, about maybe for both of you, when you think about the use cases you're seeing the most of, are there any industries that we're really seeing take off with these 3 use cases?
Oh, that's a great question. You know what, Raj, I'll let you go first for like the industries that you see the most often, then I'll talk a little bit about what we see in particular. But I feel like with Snowflake, you probably have, a significant sample size across the different industries that use the data warehouse.
So I think, the industries that we see the most are financial services and healthcare, simply because they have large volumes of unstructured data, and they're used to taking unstructured, or they're used to working with data and making decisions. So it's very natural for them to want to mine all that unstructured data they have and add it to the core of what they're doing like that. So I think that's the big piece. But the thing for me is 90% of that data inside enterprises is unstructured. If we can do some things to kind of pull some nuggets, make that useful, I think that's one of the biggest contributions of generative AI and kind of how it improves kind of all of our natural language processing tasks.
Yeah, that's a great point. And I'd say we see 2 types of like industries. One of them is, I think a lot of the types of customers that understand the value of fine tuning, either exactly as what Rod said, have data that is more unique and bespoke, and therefore they want to be able to adapt that model to something a larger commercial model wouldn't have been trained on. And we see, I'd say healthcare is probably like one area where that's come up a little bit more frequently. But the second area, and probably like our biggest volume area today, is companies that maybe have started to use OpenAI or these commercial models and are honestly like, this model performs well, but it's cost prohibitive for us to be able to use in practice. And so the number of so we see a lot of technology companies and engineering teams at tech companies that are doing all of these like mental gymnastics to avoid using GPT-4. And we're like, let's just fine tune a smaller task specific model and, we'll get that GPT-4 level of performance. So a really common thing that I hear is I want GPT-4 level performance at GPT 3.5 or less cost. And a lot of the organizations that I think have been thinking about that have been other tech companies that we work pretty closely with.
By the way, I love the framing of like boring AI, because that's pretty much like 90% of use cases. It's like, hey, we have a human paper-driven process like reviewing contracts or approving, medical claims, and so much of that can be improved by using an LLM to extract useful information. And so not always like a self-driving car that's going to drive huge benefit to the business. It's actually like, hey, how do we take hours out of these processes and make people more efficient?
Yeah. And especially because you're doing those often at bulk and at scale, and that's where the costs add up. And I think that's a great kind of one to highlight for kind of when you should be thinking about these methods.
Yeah. And actually, on that bulk and scale point, the only additional thing I want to add is one use case we've seen become pretty frequent is batch inference. Now, this is not what the LLMs, initially the interaction model was generated for. It's which was a real-time or chat application. But we see a lot of these organizations, especially like in healthcare and others, is you have like these documents, you need to run them in batch. It could run overnight as a job. But right now you kind of hit, the endpoint one at a time. And we've been investigating ways to be able to optimize for those experiences too.
Awesome. Maybe a more technical question. It's a lot of dialogue going around. When you fine tune an adapter, Devin, maybe like thinking about the customers we work with, are people usually one and done and that adapter's like good to go? Or is there retraining as new data comes in? How are people approaching that workflow?
It's a good question. I mean, I think that the reality for the answer is that it varies significantly based on the task. A lot of times, actually, organizations are able to get maybe not quite a one and done, but like they're able to create that first version of the model. And that works quite well for them until they decide, maybe weeks or months down the line that they want to be able to update that. There are some instances in which the underlying data distribution does shift. And that kind of actually, I think, requires them to be able to retrain. But in practice, we see a lot of organizations not necessarily set up automated retraining pipelines, but just doing so once they know kind of things in their business are changing. And those are some of the larger events. Roger, I don't know if you have any.
Yeah. So what I want to just point out, like the retraining is not onerous for these things. The amount of compute that you need kind of for a LoRa approach is not huge. And even if you were doing prompting, those models, right, the OpenAI models change on a constant basis. Your underlying data is changing. So yes, you might have to retrain a LoRa model, but even in a prompting world, you're going to have to recheck your prompts on a regular basis and update and modify those as underlying things change as well. But the big thing is it's not a huge big deal to be able to kind of retrain one of these things.
Okay.
And Deb, maybe one more question as we wrap up here. Some discussion around like OpenAI, and sure you can like get similar performance or better performance on a fine-tuned adapter, but what is like maybe the number one motivating factor in sort of the organizations we're talking to and why they start to move off commercial LLMs to open source?
Yeah, if you have to distill it down to one, Roger, I'm curious what you think is like the number one factor as people move to open source, and I can share which one that we see a lot. But what do you think is, before I bias it, what do you think is the number one reason?
So for me, it's just the control. You want to have your fate in your hands. You don't want to have to rely on some third party across an API for kind of essential business processes. So.
Yeah. And I would say, I think control is a really, really important one. And especially as we work with large enterprises, that tends to be one. I would say right now, honestly, cost is probably a significant one too. And, definitely like that sentiment of GPT-4 level performance, but at a lower price, I think is a huge factor driving a lot of the adoption towards open source models.
What is the typical like cost differential you see when moving from like, a handful of use cases to like over open source?
I see it actually be massive, especially if you compare against GPT-4. I'd say against GPT 3.5, it might be like a multiple 2-3x cheaper. GPT-4, I'd see it be over an order of magnitude, cost saving. And so it really ends up being very meaningful to a lot of companies that are there.
Awesome. Well, I know we are pretty much at time here, and I want to thank our speakers today for all the great content discussion. I want to thank all the folks who joined for the very active chat we had here. I think Alex did a great job of trying to respond to all the questions. If we didn't get to yours, we will follow up afterwards. You can also join our Discord. The link has been posted on there, or you can go to our Predibase website, click the Learn menu option, and find the Discord link there as well. And of course, you can always reach us. You can reach me, Michael at Predibase, or any of our speakers as well on LinkedIn. And support at Predibase too if you have any questions. Thank you for joining us, and the recording will be sent out after, and we'll see you on the next one. Have a good one, everyone.
Thanks, everyone. Thanks, Raj.
Thanks. It was great.